Welcome back to Up in the Air, and thanks for joining us on the second half of this year's season. I'm Meredith Fish.
And I'm JP Nicola. We've seen quite impressive snow totals across central PA this week.
Yeah, we have. And just from Blizzard Juneau, State College received 8.6 inches of snow, with the current snowpack being 11 inches.
Although State College totals were similar to forecast totals, a more eastern track of the storm led snowfall totals to be overestimated in cities like Philadelphia and New York City.
Wow. Well, still, I'm happy we were in Boston during this storm. But moving on to tonight's show, we have a lot to cover this evening.
We will be covering the California drought, new severe weather research, and introducing the North Atlantic Oscillation.
And for now, this is Update in the Air.
Two separate analyses done by NASA and NOAA scientists have shown that the calendar year of 2014 was Earth's warmest year since 1880. In fact, the 10 warmest years on record have occurred since 2000, with the exception of 1998. John Grunsfeld, Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington, says the observed long-term warming trend and the ranking of 2014 as the warmest year on record reinforces the importance for NASA to study Earth as a complete system, and particularly to understand the role and impacts of human activity. Since 1880, Earth's average surface temperature has warmed by about 1.4 degrees Fahrenheit, largely driven by the increase in carbon dioxide and other human emissions into the planet's atmosphere. Phenomena such as El Niño and La Niña, which warm and cool the tropical Pacific, are thought to have played a role in the flattening of the long-term warming trend over the past 15 years. However, 2014's record warmth occurred during an El Niño neutral year.
Earlier this week, Meteostat-7, a geospatial weather satellite, is officially the longest-serving operational satellite in the European Organization for the Exploitation of Meteorological Satellites history. Launched in September of 1997, this satellite is the seventh and last of the Meteostat first-generation series. In June 1998, Meteostat-7 was positioned over 0 degrees longitude with an operational expectancy of 5 years. In July 2006, the satellite was moved to 57.5 degrees east over the Indian Ocean to provide the only Indian Ocean imaging coverage. The satellite continues to be in good health and is expected to provide weather data until the end of 2016 or the beginning of 2017.
There is the potential for an improvement of California's drought in the form of atmospheric rivers, which are narrow channels of water vapor that extend for thousands of miles, pulling moisture from the tropics and eventually delivering it to the West Coast. Research shows that these atmospheric rivers have broken 40% of California droughts since 1950. A major field experiment has been launched, and through the end of February, a group of government and university scientists will collect data from airplanes and ships off the coast of California. This knowledge should help communities better prepare for flooding and allow water managers to make better use of storm runoff. Atmospheric rivers are very important for California's water supply, especially for the Sierra Nevada snowpack, which remains at less than half of normal. However, with the severity of this current drought, experts warn that too much rain at once could bring devastating flooding.
While snow plunders the Northeast this week, the Sierra Nevada ski resorts have been lacking in snow coverage for many days now. The unseasonably warm weather and lack of storms have disrupted the ski season in Northern California. Some resorts have had to temporarily close while waiting for more snowfall, while others are trying to produce enough artificially. Although ski conditions are beautiful, the lack of epic snows have kept the crowds away. Typically, this region experiences high pressure during January, but early winter storms builds the snowpack to sustain the mountains until later in the season. Unfortunately, this was not the case this year, as the earlier storms had a higher snow level, meaning snow starts higher up on the slopes. Many owners are trying to stay positive throughout this time and continue to provide open ski resorts for their customers.
The U.S. Department of Energy has allocated $2.5 million to help improve wind forecasting. Vaisala, based in Louisville, Colorado, will research the atmospheric processes that generate wind in mountain valley regions. The data will be used to improve wind weather models for short-term wind forecasts, allowing energy plants to operate wind turbines closer to maximum capacity. Mountain valley areas pose additional challenges, including varying degrees of soil moisture and surface temperatures, which make wind energy output forecasting quite difficult. Research will be performed in the Columbia River Gorge region of Washington and Oregon. The data will then be shared in real time with the National Oceanic and Atmospheric Administration and the Energy Department's national laboratories to develop improved atmospheric simulations for the weather research and forecasting model.
New research at the University of Alabama Huntsville is looking at the sudden jump in the number of lightning strikes inside a thunderstorm as a predictive measure for severe weather. The transformation of a normal storm into a supercell with a large rotating updraft, also known as a mesocyclone, can be determined by the sudden increase in lightning. Due to the severe weather that comes from supercells, this research is important to help issue timely warnings to the public about straight-line winds, hail, and tornadoes. Hoping to develop algorithms to ultimately be used by forecasters, researchers are actively working to understand the development of supercells. Currently, the lightning jump is being tested as a forecast tool by the National Weather Service in Huntsville, Alabama, and at testing facilities in Norman, Oklahoma. And those are all of this week's Update in the Air stories. We'll be right back after this.
2014 was the hottest year on record. The finding was announced today in a new report from NASA's Goddard Institute for Space Studies in New York. Each year, the Institute produces a global temperature analysis using readings from weather stations around the world. The map seen here shows long-term changes in Earth's temperature compared to a 30-year baseline. Red, orange, and yellow are warmer areas. Blue is colder. Since temperature records began in 1880, the global average has increased by 1.4 degrees Fahrenheit.
And that might not seem very much, but in terms of the climate, it's actually quite a big deal.
Scientists expect global and regional fluctuations in temperature from year to year due to changing weather patterns. In 2014, the Midwestern US experienced a cold winter, but parts of Western US hit record high temperatures. When looking at decades worth of data, the ranking of 2014 as the hottest year reinforces the long-term trend of rising global temperatures, a trend driven by the increase of carbon dioxide levels in the atmosphere.
Carbon dioxide levels are increasing because we're taking carbon out of the ground, mainly as coal, oil, or as natural gas, and we're burning it. When you burn carbon, you produce carbon dioxide, which contributes to the planet's greenhouse effect. And as we continue to increase that, we're going to continue to see warming and more records being broken, not every year, but on a pretty regular basis.
Thanks for joining us again.
Now we want to introduce the work of the Climate Dynamics course here at Penn State.
Students Lee Hastings, Nicole Marsh, and Christy Ruel will tell us about the North Atlantic Oscillation.
Before the advantages of satellite, before the advantages of radar imagery, Sir Gilbert Walker discovered the North Atlantic Oscillation, or NAO, in the 1920s. Walker was not a meteorologist. He graduated from the University of Cambridge with a mathematics degree. He was in charge of the India Meteorological Department, organizing Indian weather observations. During this time at the department, he found correlations between meteorological events and monsoons. He called it seasonal forecasting. The NAO is a teleconnection. Teleconnections are a resource that help develop the weather and climate pattern over a small time scale and over the course of years. Using one measurement, teleconnections can show climate variability that reflects circulation and weather patterns over large areas. The NAO focuses on surface sea level pressure differences between a nearly constant area of low pressure near Iceland and nearly constant area of high pressure near the Azores.
Forecasters track the NAO by comparing the 500 millibar heights from Iceland to the Azores. When the NAO indices are correlated with positive values, low 500 millibar heights are marked over Iceland and high 500 millibar heights are marked over the Azores. The subpolar low and the subtropical high are stronger than average at this time. The large height gradient between Iceland and the Azores causes a pattern of fast upper air westerly winds blowing across the Atlantic Ocean, creating the fast zonal jet stream.
The NAO explains variability in winter weather across the eastern United States through precipitation types and differences in ocean temperatures. During the positive NAO phase, the eastern United States sees an increased number of rain events in the winter due to mild milder temperatures. The positive phase is associated with a strong pressure gradient between the high and low pressure systems. A large pressure gradient sets up for a strong jet stream, making it difficult for the cold air from Canada to push south.
The jet stream and storm track generally flow from the northeast United States to Ireland and the UK. Warmer, wetter than normal winter seasons can be seen in the northern regions of Europe, and drier than normal conditions can be seen in southern Europe and northern Africa. The location and faster speed of the jet stream does not allow the colder air from Canada to escape down to the eastern United States. This is why we see the warmer temperatures in the winter. With above average temperatures across the eastern United States, below normal snowfall is seen. The overall climate variability during a positive phase NAO are higher air temperatures in the winter and below normal snowfall in the northeastern United States. As seen in these two maps indicating the snow depth at the end of December during a year of a positive NAO, 2011, and a negative NAO, 2010.
During a negative NAO, the opposite happens in the northeastern U.S. A negative NAO corresponds to a weaker pressure gradient over the North Atlantic, giving the jet stream more flexibility to dive south. Cool Canadian air coming south means more rain events become snow events. Take, for example, the winter of 2009 to 2010. The NAO was in one of its top 2 most negative phases. That winter, Philadelphia recorded 78.7 inches of snow, more than 4 times their seasonal average. And Pittsburgh, which averages 41 inches of snow per winter, recorded just over 77 inches, making it their 3rd snowiest. Similar snow totals occurred in the winter of 1970 when the NAO remained negative. The NAO varies between the positive and negative phases almost evenly. In 64 years, the NAO has been positive 51% of the time. The NAO alone can't forecast the weather, but it can provide meteorologists with a climatic pattern to hint at what's to come, especially for the northeastern U.S.
For Up in the Air, this is Lee Hastings,
Nicole Marsh,
and Christina Ruel.
Thanks for tuning back in.
Hunter Williams is standing by at our climate wall to give us the 8 to 14-day outlook.
Take it away, Hunter.
Thank you, JP and Meredith, and thank you to everybody for tuning in for our first episode of Up in the Air here for the new semester. Now, we're getting to that time of the winter where people are starting to get a little bit tired of the snow and a little bit tired of the cold. Now, as we direct our attention to the snowfall map here, unfortunately, plenty of snow to go around, especially for those of you in the Northeast. Now, we just saw very significant snowfall, upwards of 2 feet in some areas, as you can see from a very powerful coastal storm here. So parts of the Northeast seeing plenty of snow to go around. Now, as far as what you can expect for temperatures over the next 8 to 14 days, if you're a fan of the warmer weather, you might want to turn your head right now because you're not going to like what you see. Plenty of blue to go around. For those of you living here in the East, well below normal, temperatures likely through New England and stretching down through parts of Pennsylvania, but really just about everybody in the East, including the Southeast, up through the Midwest and pushing out through parts of Texas, getting in on these cooler or below average temperatures as we go through the next 8 to 14 days. But pushing out west, a much different picture. Everybody getting in on the warmer temperatures rather than the colder temperatures from the east. As you can see, it's above normal temperature bubble where we don't like to see it. That's the drought-stricken areas here through parts of Nevada and through south central and north central California there. So unfortunately, that's not what we like to see going forward with the drought in those areas. But moving towards the precipitation, below normal precipitation, likely through parts of northern New York, down through Pennsylvania and extending through the Midwest and pushing out towards the Mississippi River, down towards Florida in the southeast, though, parts of North Carolina, South Carolina, Georgia, and pushing down through Florida, getting in on above normal precipitation through the next 8 to 14 days. But as we push out west, a bit of good news for those of you through parts of Montana and Idaho here. Now, a few weeks ago, these areas saw a slight drought, not what we're seeing here in California, not of that magnitude, fortunately, but we are seeing above normal precipitation likely through the next 8 to 14 days for these areas, so that's certainly good news. But unfortunately, below normal precipitation likely in the hardest hit of these drought-stricken areas here through parts of Nevada and through parts of California. So unfortunately, through the next 8 to 14 days at least, does not look like relief is on the way for these areas. Once again, I've been student meteorologist Hunter Williams. Back to JP and Meredith.
Thanks, Hunter. I sure could use a break from the snow.
Me too. We would also like to introduce a new member of our team, Amanda Reynolds.
We are excited for you to be a part of the show and look forward to your future contributions.
And that's all we have for this week. Thank you to the Penn State students for contributing to the show.
Tune in next week to catch another episode. But for now, I'm JP Nicola.
And I'm Meredith Fish. See you next time, Up in the Air.